Semiconductor chip manufacturing capabilities are currently limited to very few regions in the world. With supply chain disruptions during the pandemic and recent geopolitical tensions, many companies and countries, including India, have realized the importance of investing in chip manufacturing infrastructure. So in this video, we will tell you the technology behind manufacturing a semiconductor chip. Let's start. What is a semiconductor chip? How is it manufactured? A semiconductor has properties between a conductor, which conducts electricity, and an insulator, which does not. In its purest form, a semiconductor is a very weak conductor of electricity. However, its electrical properties can be changed by adding small amounts of certain substances called dopants. By taking a pure semiconductor and carefully injecting certain parts with specific dopants, complex circuits can be printed on the semiconductor. The process is crudely analogous to creating an intricate work of art on a paper or a wall by using a bunch of stencils and spray paints of different colors. The stencils are called masks in the industry, and the paint is analogous to the dopant. What is a transistor? The transistor, one of the earliest electronic components to be built using a semiconductor, is an extremely versatile device. In its most popular form, it can function as an electronic switch. A typical semiconductor chip can have millions or even billions of these interconnected switches that work together to perform various logical and computational operations. A transistor can also function as an amplifier to amplify the weak signal received by your cell phone, and is an integral part of circuits that generate and process high-frequency signals, such as those required in wireless communication technologies. Today, all these different avatars of the transistor are routinely packed into a single semiconductor chip, such as the Wi-Fi chip in your mobile. The transistor demonstrated how a single device could be built out of a piece of a semiconductor. Printing multiple devices onto a single piece of a semiconductor to create entire circuits was the next leap. Both these breakthroughs laid the foundation for the semiconductor revolution and have been aptly recognized by Nobel Prizes in 1956 and 2000. What is fabrication technology? Technology has progressed at a relentless pace since the semiconductor chip was first conceptualized more than 6 decades ago. Newer manufacturing technologies have been introduced at a regular cadence. The level of miniaturization of the semiconductor has increased by orders of magnitude. Sticking with the stencil analogy, this is mainly due to the stencils being able to etch smaller and more intricate patterns. There have been equally impressive gains in the switching capability of the transistors. They are able to switch on and off faster, meaning more computations per second, and with lesser power consumption, resulting in longer battery life and lesser heat dissipation. The industry has used labels like 45 nanometer, 28 nanometer, and 16 nanometer to introduce each new manufacturing technology. NM is short for nanometer and refers to an extremely small unit of length equal to 1/1,000,000,000 of a meter. These numbers convey the level of miniaturization that is achievable using a particular technology. So smaller is better. Though not always accurate, you can think of this number as representing the dimensions of a single transistor. While traditionally electronic circuits have been laid out flat on the semiconductor, researchers are increasingly looking to capitalize on the third dimension, or height. As the length and breadth of a transistor switch decreases, increasing its height can help ensure reliable performance. Stacking entire circuits on top of one another is another way to continue to shrink semiconductor chip sizes. Please subscribe to our channel and watch till the end. Also comment us for providing more content like this. What is known as a wafer? A semiconductor chip is manufactured much like a postage stamp. A sheet of stamps is printed on a piece of paper, and then each individual stamp is cut out. Similarly, an array, typically 300 to 400 of chips, are printed on a circular piece of semiconductor called a wafer in industry parlance. This is then diced to create individual chips. A larger wafer size allows more chips to be printed on a single wafer, which makes chip production faster and cheaper. Wafer sizes used in the industry have constantly been increasing. The current state of the art is 300 millimeters, which is approximately 12 inches. This refers to the diameter of the wafer. Efforts are ongoing to move to a 450 millimeter wafer size. While moving to a larger wafer size has its technical challenges and capital expenses, it has proven to be economical in the long run. Once the wafer has been diced into chips, each individual chip has to be packaged in a protective covering. Tiny wires have to be routed from the device to the boundary of the package. Some of these wires supply power, while others are used for feeding in and reading out signals and data. A chip also has to be tested. This includes verifying its functionality and stress testing, subjecting the chip to high temperatures and voltages to ensure reliability during its lifetime. All this is performed in an assembly and test plant. What does India's semiconductor ecosystem look like? India has had a thriving chip design industry since the 1990s. Due to the magic of computer-aided design, it is possible to design a semiconductor chip entirely in software. The process of specifying the functionality of a chip, translating this functionality to electronic circuits, validating the circuits, and optimizing for speed, power consumption, and size can be done by a team of skilled engineers sitting at their desktops. The final design is abstracted into a file and sent to a fabrication plant for manufacturing. It's a bit like designing an entire graphic novel on your laptop and then sending the PDF to your publisher for printing. India's foray into semiconductor manufacturing will benefit from the existing ecosystem for chip design, which was fueled by a steady supply of electronics and computer engineers. Semiconductor manufacturing, being an essentially interdisciplinary endeavor, could present opportunities to a wider array of professionals, such as process and control engineers, data scientists, material scientists, physicists, and chemical engineers, to contribute meaningfully to this industry. The Tata Group has partnered with Taiwan's Powerchip Semiconductor Manufacturing Corporation, or PSMC, to set up a 300mm wafer fabrication plant in Gujarat. It will roll out its first 28nm chip in 2026. 2 assembly and test plants in Gujarat and Assam have also been recently approved by the Government of India. Subscribe to our channel and don't forget to hit the like button if you enjoyed this video. Also, please comment if you have any interesting topic.